Hello friends, welcome once again to 7th Sense Aptitude Prep. This is the second video on clocks. We look at some easy problems here. Uh, we strongly recommend that if you've not watched video 1 that you do. In that video we looked at what are the two important hands of a clock, the hour hand and the minute hand. We looked at the angle made by the hour hand and the minute hand in 1 hour, in 1 minute, in 12 hours. We've looked at all of those concepts. Suggest that you watch that video. And we have also looked at the time taken for the minute hand to make the same angle as the hour hand. So these numbers, the angle made by the hour hand and the minute hand in 1 hour and 1 minute, very, very, very important. So just to recap, angle made by the hour hand in 1 hour is 30 degrees. Angle made by the hour hand in 12 hours is 360 degrees. Angle made by the hour hand in 1 minute is half a degree. Angle made by the minute hand in 1 minute is 6 degrees. Angle made by the minute hand in 5 minutes is 30 degrees. Angle made by the minute hand in 60 minutes is 360 degrees. Okay, so we looked at all of those. In this video we look at the angle between the hour hand and the minute hand for a given time. Okay, we look at some problems on this. We look at the fraction of the hour when they specify some two different times, and for clocks which are either running fast or slow, we'll figure out the exact time after a specific number of hours have passed. So these are all questions that we look at. Problem type 0. Okay, we call it problem type 0. That's not a mistake, because this is the absolute basic but a very important concept that we will encounter. If they ask you to find the angle between the hour hand and the minute hand at x o'clock, okay, so in clocks the angle doesn't depend on whether it is am or pm, right? So 5 p.m. and 5 am, the angle made is the same. So let us look at 3 o'clock, right? So as we look at 3 o'clock, so if you'll see that the hour hand is now at 3 and the minute hand is at 12. So we know the hour hand in every hour is moving 30 degrees. So at 1 o'clock, the angle, the minute hand is still there, right? It has moved, correct, from 12 o'clock. It has moved, but it has come back again to 12. When it is 1 o'clock, the minute hand has come back again to 12. Again it moves, and at 2 o'clock, the minute hand again comes back to 12. So at 1 o'clock, it is like this. At 2 o'clock, it is like this, right? We know the hour hand is moving 30 degrees every hour. So at 1 o'clock, the angle made by the hour hand and the minute hand is 30 degrees. At 2 o'clock, the angle made by the hour hand and minute hand is 30 plus 30 is 60 degrees. So see, just to verify, at 3 o'clock, you know, the clock is like this. You know, this is 90 degrees. So this is 30, 60, this will be 90, which is accurate. So at 4 o'clock, it makes 120. Add another 30. At 5 o'clock it makes 150. At 6 o'clock it makes 180 degrees, which is also correct, because at 6 o'clock the hand is this way. So this is 180. So very, very simple. The angle between the hour hand and the minute hand at x o'clock, okay, you multiply x by 30 degrees. Multiply x by 30 degrees. So if I ask you what is the angle made by the hour hand and the minute hand at 7 o'clock, you say 7 into 30 degrees, which is 210. Okay, so very, very important. X o'clock, x multiplied by 30, that is the answer. Problem type 1. Now find the angle between the hour hand and the minute hand at 8:30. Okay, so we know that there are two angles that are found. I'll come to what those individual angles are. Let me just roughly draw 8:30 now for you. Okay, so if you see here, this is 9, this is 8, this is 6. It will be somewhere like this. At 8:30 it will be like this. So how do we find out the angle between these two hands? Now it's not 8 o'clock or 9 o'clock. The minute hand has also moved. So firstly we figure out how much the hour hand has moved by. At 8 o'clock, let's say at 8, the hour hand has moved by 8 into 30, which is 240. Okay, now, but it's not 8, it's 8:30, right? In the additional 30 minutes, how much has the hour hand moved by? In 1 minute, the hour hand moves by half a degree. You saw that. So in 30 minutes, the hour hand has moved by 30 into half, 15 degrees. So our hand has moved by a total of 240 plus 15. It has moved by 255. So is 255 the answer? No, 255 is not the answer, because the minute hand has also moved. If it is 8:30, the minute hand is moved by how much? So in 60 minutes, the minute hand moves 360 degrees, right? So in 30 minutes, it is moved by 180 degrees. Okay, or you can do 30 into 6, because in the minute hand moves 6 degrees every minute, you will get the same answer as 180. So what is the angle? Angle is 255 minus 180. Our hand has moved from 12 to 8 and beyond 8, because it's 8:30 now. The minute hand has moved to 30, which is here. This is the minute hand. So this angle is 255 minus 180, which is equal to 75 degrees. We also have a second angle form. If this is 75, there is also a second angle form, right? So let me just draw that again. This is, let's say if this is around 8:30, right? And this is the 75 degrees that we have calculated. There's also one more angle formed here. How do you find that angle? This entire part is a circle, right? So that would have been 360. If this is 75, this would be 360 minus 75. 285. So this angle is 285. This angle is 75. Do you know what this is called? This angle, that angle is known as the reflex angle, which is asked in the second question. So when they say find the reflex angle between the hands of a clock at a given time, we have to find the angle like we generally find and then subtract that angle from 360. So let us roughly draw 11:45. I'll just draw the numbers that are important for us. At 11:45, or somewhere like this. Okay, and is somewhere like this. So we have to find out this angle because the reflex angle is asked. But if we find this, angle, subtract this from 360. So at 11:45, how much is the? Let us move a little faster so we know how to solve this generally. At 11, the R end has moved by 11 into 30, which is equal to 330 degrees. That is what the R end has moved by. But there's another 45 minutes. So how do we figure out 45 minutes? 1 minute is half a degree. 45 minutes is 45 into half, which is equal to 22.5 degrees. 22.5. So totally it is 352.5. That is what the R hand is moved by. The minute hand in 45. So in each minute it moves 6 degrees, right? 6 degrees. So in 45 minutes it has moved 45 into 6, 270 degrees. So now what is the angle? What is this angle? This angle is now 82.5. Yeah, we can also figure out. It's slightly less than 90. See, if you see this, it's also slightly less than 90 because the R end is not moved until 12. Now, this is 82.5 now, but they've asked the reflex angle. So for the reflex angle, you just do 360 minus 82.5, 277.5. That should be your answer. 277.5. Very, very important. So we looked at that this is not a perfect R. It's not 8 or 9. It's not 10. There is a time given, and that time is such that the minute hand is also moved. So we figure out the angle moved by the R hand. We figure out the angle moved by the minute hand and subtract. And for reflex angle, we follow the same approach, but we subtract that angle from 360. Okay. Now the clock has started at 12. So when they don't specify when the clock has started at 12, we calculate the angle from 12. Okay, we assume that the clock has started at 12 and then calculate how much each has moved. Now here you see that the clock has started at 3. So if you see, it was like this. Now they're asking at 20 minutes past 6, right? So the clock is somewhere, sorry, this looks more like 7. It's somewhat like this. Okay, the clock is 6:20. So this is 6, this is 4, so it's 6:20. At this time, the R end is moved by how much? So be careful, it does not start at noon. So we calculate, so two ways to do it. One is to calculate from 12 and then subtract from 3, or just calculate from 3. So assume it is at 3. If it is moved past 6, right? So from 3 it is moved by 1 hour, it becomes 4, 2 hours it becomes 5, 3 hours it becomes 6. So the R hand has moved only 3 hours because it's from 3 o'clock. So the R hand has moved 3 hours into 30 degrees, which is equal to 90. Plus, it has moved another 20 minutes, right? It has moved another 20 minutes would mean per minute it moves half a degree. For 20 minutes, it will move 20 by half, 20 into half, makes it 10 degrees. So if you want to calculate this, it is only 100 degrees because from 3 o'clock. If it had not said this, if this was not asked, if this was not given, and if you had to find out at 20 minutes past 6, the R hand has moved by, then we assume it is from 12. And then we say it has moved as the R hand has moved 6 into 30, 180, and then for another 20 minutes we would have added 10 degrees. So this would have been 190 degrees. So this is only for 12 o'clock or when they don't specify the start time. For both those instances, you do this. Okay, we do this. This is for this question because they've asked from 3 o'clock, and from 3 o'clock there are only 3 hours. 3 hours into 30 degrees, 90, and then for another 20 minutes we do 10 degrees. Okay, so that is the problem type 1 which continues. Now problem type 2. Problem type 2 is where they ask you to find the fraction of hour that has elapsed. So here they've looked at 3:38 a.m. and 4:26 a.m. Sometimes they don't specify whether it's AM or PM, then we assume that it is the same, right? We assume either it is both are AM or both are PM. So don't think that it has moved 12 hours and then become the other AM has become PM. Don't complicate things. So I'm just specified here 3:38 a.m. and 4:26 a.m. What is the fraction of the hour? How do you find out the fraction of hour? So we have the clock moving from 3:38 to 4. When it moves from 3:38 to 4, we have 22 minutes, right? And from 4 to 4:26, we have 26 minutes. Sorry, not 26 minutes. We have 26 minutes. So that totally becomes 48 minutes. So 48 minutes, that is not the answer. They've asked what is the fraction of the hour. So if you have to find the fraction of the hour, 1 hour is 60 minutes. What is 48 minutes? How many hours is it? It is 48 by 60, 4 by 5. Fraction of the hour is 4/5 of an hour. 4/5 of an hour. Okay. In this question, see, they have not specified whether it's AM or PM, so we don't worry too much about it. What is the fraction of the hour between the time of 7:26 and 8:08? So 7:26 to 8, we'll have 34 minutes, and 8 to 8, okay, that is another 8 minutes. So totally this becomes 42 minutes. The fraction of the hour is 42 by 60, 7/10 of an hour. 7/10 of an hour. Okay, this is problem type 2. Not very frequent, but I thought we'll also specify that because it comes under an easy concept. Now this is where the clock is either fast or slow, and then you have to find the correct time. The correct time is set in a clock at 9 a.m. right? So be very careful about the AM or PM here because they have specified it. Correct time is set in a clock at 9 a.m. In 24 hours, which means in a day the clock runs 15 minutes faster. What does it mean when it says the clock runs 15 minutes faster? Is that in 24 hours, if the clock is showing 9 a.m., okay, in 24 hours it will show 9 a.m. The actual time is only 8:45 a.m. That is what it means when it says the clock runs 15 minutes faster. What is the correct time? And the clock shows 3 p.m. on the next day. So we have firstly to find out how many hours have passed. So 9 a.m. on one day to 9 a.m. on the next day, okay, is 24 hours. Okay, but it's not 9 a.m. on the next day, it is 3 p.m. on the next day. So 9 a.m. on next day to 3 p.m. on the same day is another 6 hours, right? So 9 in the morning to 3 in the afternoon. So we have 30 hours that have passed. 30 hours have passed. In 24 hours, it is 15 minutes fast. In 30 hours, it is going to be, we figure out 15 into 30 by 24, you will get the answer as 22.5. You will get 18.7. Okay. The other way to look at it is, in 24 hours, it is 15 minutes faster. So 6 and an additional 6 hours means it is 6 is 1/4 of 24 hours, right? So additional time that gets added is 1/4 of 15 minutes. 1/4 of 15 minutes is 15 by 4, which is equal to 3.75. So 3.75 minutes, it gets slow from 9 a.m. to 3 p.m. on the same day. But in the previous 24 hours, it has gotten slow by 15 minutes. I get 18.75 here as well. Two methods, whatever is convenient to you, you please do it. So here 9 a.m. of one day to 9 a.m. on the next day, 24 hours have passed. 9 a.m. on the next day to 3 p.m. on that next day, which is the same day, is another 6 hours that have passed. So 30 hours have passed in total. In 24 hours, it is fast by 15 minutes. In 30 hours, it is fast by 15 into 30 by 24, which will give you 18.75. Okay, so that is the answer. The correct time is set in a clock at 10 a.m. In 24 hours, the clock runs 20 minutes faster. So let us see 6 p.m. on the next day, how much time has passed. So 10 a.m. on Monday to 10 a.m. on the next day is 24 hours. Next day 10 a.m. to 6 p.m. How many hours have passed? Don't get confused with AM PM. 10 in the morning to 6 in the evening is another 8 hours that have passed. So totally 32 hours have passed. Okay, for 24 hours, it is 20 minutes faster. For 32 hours, how much is it faster by 20 into 32 by 24? 80 by 3. Okay, so you get 26.66. Now what does this mean? Now they have not asked you to find this value, right? They have asked you to find out the correct time. What does 18.75 minutes mean? It means that the clock is faster by this much. So what is the correct time? You can't subtract 18.75. What does 0.75 of a minute mean? Okay, 1 minute is 60 seconds. Okay, is 60 seconds. Now what does 0.75 minute mean? 3/4 of a minute is what? So 3/4 of a minute is 60 into 3 by 4, which becomes 45, which is 45 seconds. So the clock, when it shows 3 p.m. on the next day, it is ahead by 18 minutes and 45 seconds. So 0.75 minute means 45 seconds. So what is the time you subtract 18 minutes from 3 becomes 242. Okay, and then subtract another 45 seconds, which means it is 2 o'clock 41 minutes and 15 seconds. Okay, so that is what this means. When you have to look at 26.66, okay, let me just erase some portion so that we have space to solve this. We now have the answer as 26.66 for the second question. So let me just erase a little bit here so that I'll have some space to draw. So 26.66 minutes, right? Let us see what is 0.66. 0.66 is also 2 by 3. So 1 minute, if it is 60 seconds, 2/3 of a minute, which is 0.66 minutes, is 60 into 2 by 3. That is 40 seconds. Okay, it's 40 seconds. So when the clock is showing 6 p.m. on the next day, so I'm solving this problem here. So we've gotten the answer as 26.66. When it's showing 6 p.m. the same day, the real time is 6 p.m. minus 26. Okay, so if you had subtracted 30, it would have become 5:30. So the answer is 5:34 and another 40 seconds. Okay, so 5:34 minus 40 seconds, meaning 5:33 and 20 seconds. So you see here 5:33 and 20, add 40 seconds to this, it becomes 5:34, and add 26. So it becomes 6 o'clock. So it is the correct time. When it is showing 6 p.m. on the next day, because the clock is running faster at 6 p.m., it would have become 26.66 faster. 0.66 is 40 seconds. So it is 26 minutes and 40 seconds faster. So we subtract 26 minutes and 40 seconds from the given time. So what are the things we looked at and learned from this video is we looked at in the previous video, we looked at the angle when it is x o'clock, right? 3 o'clock, 4 o'clock, 7 o'clock. Here, when the minute hand is also moved, so 7:30, 8:48, so all of those problems, angle between the hour hand and the minute hand for a given time, you find angle covered by the hour hand, and then you find angle covered by the minute hand, and you subtract one from the other. We also found out how to find the reflex angle, which is subtracting the angle from 360. Then we looked at the fraction of the hour between two different times. So the time that has elapsed between those two times, and then the fraction of the hour would mean dividing by 60, and you'll get the fraction of the hour. And just now we looked at clocks running fast or slow. If they're fast or slow, how do you figure out what is the exact time? If it is fast, you subtract the time from the time that is displayed. And if that is what we looked at, right? In the previous here, we got some time and then we subtracted. So here we got 18 minutes 45 seconds. So we subtracted that from 3 and got this. Here we got 26.66, which is 26 minutes and 40 seconds. So we subtracted. This is because the clocks were faster here. If it was slower, then you will have to add. So we looked at all of this. Now, practice questions on these concepts. You only get better at aptitude and you get faster and you get more accurate when you practice a lot. And then we look at even more concepts. You see that the difficulty level of both the problems and the concepts have increased. You'll learn even more from video 3. In the meanwhile, if you haven't yet subscribed to our channel, please subscribe to 7 Sense Aptitude Prep, like the video and share it with your friends, and learn more as we upload concepts and problems. And for all the other courses and test series and company tests and packages, please visit our website www.7sensetalent.com. You can sign up and log in there and start practicing. Okay, if you have any queries, please put that in the comments below. We will solve that and respond either in the comments, or if the concept is substantial, we'll create a separate video